I'll just take 1 second to frame up my first question to see sort of where you guys stand on a spectrum of possibility here. In 1868, it was hard to pick up a newspaper without hearing breathless, boosterish coverage about the transformative potential of the railroad and the oncoming transcontinental line that was nearly completed at that point. In the 1950s, it was hard to pick up a newspaper and without hearing the same kind of boosterish coverage about the transformative potential of the atomic age. In 1955, the New York Times quoted an expert on this question saying that within 10 years, we're all going to be using atomic vacuum cleaners. And so sometimes the news gets it right. There's a big trend out there that could totally change the world. Railroads changed how all cities operate, how human life is lived in a lot of ways. On the other hand, I'm a journalist, and it's important never to underestimate the ability of journalists to be certain and wrong. And in the case of atomic power, none of us has a nuclear vacuum cleaner. So the question I'd like to start with, and we'll just go down the line, have all of you give us an answer, is, it's hard to read the news today without seeing all these boosterish, breathless, excited stories about AI. So how do we know if this is all real, if this is going to transform life as promised? How do we know if it's not just a bunch of hype? Go ahead, Stan.
Yeah, I guess I don't really view, I don't view AI that different. I think it's the current incarnation in the name that we describe a process that's been in place probably from the 60s and 70s with information technology, and it's the current cache, it's what's in vogue to describe that, but it's the use of computers and increasingly the synthesis between computer technology and data, and that's led to a set of technologies which we call machine learning and AI today, but it's part of a long lineage which has a longer history and is ultimately going to be as transformative, I think, as trains were, perhaps not as transformative as electricity was, but is going to be very transformative.
What do you think, David?
Part of what we hear naturally is in the nature of the press. The press wants to have a big story and an exciting story for the future. And, AI and all of science is done by mere human beings, and it's naturally cyclical. The way people get excited, there was a huge boom in the 1950s at the very start, and people were looking at AI and electronic brains. There was another very big boom in the 1980s when expert system technology began being developed and used widely. And there's a big boom today, and these booms wouldn't keep coming back if we weren't making actual progress, and we're making extraordinary progress. Just ask Garry Kasparov. There are a lot of people in a position to know that AI technology is real and has done things that would have been dismissed as impossible a generation ago. On the other hand, just to conclude, AI is stuck technically in the larger sense. AI doesn't understand the human mind. AI is increasingly distracted by specific algorithms to solve specific problems. The big noble project of understanding the mind is still just as important, just as exciting scientifically and philosophically. We're not giving it as much attention. We got stuck there, and unfortunately that part of the field not going as well as the more applied parts.
So AI is making progress, but it's stuck. What do you think, Guru?
Well, I actually think AI is one of those big transformative technologies, and here's my reason. Back in the Industrial Revolution days, right, we needed machines to augment our physical abilities, right? We built all of these, trains and cranes and everything else to augment ourselves because we just could not do many things that we wanted to do. And I think we have a kind of a similar problem today, but with our cognitive abilities. We have reached a point where we have so much data that is bombarding us and so much knowledge that's bombarding us. Even the growth of knowledge is exponential, not just the growth of data, that we need tools to augment our cognition. And that set of augmentation tools, I would say, are going to combine with our own natural intelligence in order to create a system that is way better than either just a machine, which is autonomous, or a person who is just using our natural brain. So in a sense, I kind of define AI as augmented intelligence as opposed to artificial intelligence, because I think the term artificial has confused a lot of people. I mean, it was an unfortunate term, I think. Artificial kind of implied that we wanted to replicate the human brain just like it did everything. I don't think that's the right view, because that is a very, very difficult and a long-term potential objective, which we're not that close to. But on the other hand, augmented intelligence, or as in IBM we call it cognitive computing, is actually making a huge amount of progress. And I see these machines that can augment pretty much every professional or personal decision-making task in every industry. Just to give you an example, I was with my tax advisor just last weekend, and he used Watson to turn around and say, I can maybe help you with your taxes with Watson. So I think it's transforming everything.
Ralph, what do you think? Is this the railroads? Is this the nuclear vacuum cleaner?
It's the railroads. I think, let me ask the question, how many people have an Echo here, an Alexa device? So you see, this kind of technology, says about 10% of the room, would not be possible without AI. I think it's real, it's there already. I would argue it's not something in the future. It's going to get more profound. I mean, we are at the beginning, but voice recognition, I think the analysis of video signals, the fact that we have a lot more digital data. Where I agree with David is there's this view between, is it a tool or is it a replacement? Is it sort of, does it have the task to completely mimic and replace what the human cognition does? And I think it's a tool. And this notion of sentience, I think that's probably a long way out, and I'm not sure if that's really transformative, but what we call machine learning, as you were saying, pattern recognition, and patterns that are more complex than the human eye can spot. It's something that, particularly as we have more sensors that digitize the real world, becomes much more relevant. It's already in voice recognition, it's in online shopping, it's in online advertising. It's actually there already. So that train is already on its track.
That sounds right to me, Ralph. I mean, we're witnessing tremendous engineering successes in our own lives, right? They're in our pockets, they're online. And so I'm wondering, in terms of putting those kinds of engineering successes into the proper context, how do you make sense of both what's marvelous but what the real transformative potential is? I'm wondering, Guru, since you work for a company that's been at the center of a couple of storms of media attention after a couple of very high-profile engineering victories, right? David brought up Garry Kasparov's loss to IBM's Deep Blue, of course. Then your Watson program absolutely trounced the two reigning champions of Jeopardy. I mean, this wasn't even a defeat. These guys, they were handed their rear ends on television. And the coverage was equally breathless, was by turns, anxious, but also celebratory. And so I'm wondering, what's the best way for us lay people to square that momentary reaction with the real long-term potential of the underlying tech?
Picking up from where Ralph left off, right? I think understanding speech and images and all of that is really making tremendous amount of progress. But I think the real breakthrough that enabled us to get Watson into so many different industries is the idea of understanding language. I would kind of claim that language is the highest form of cognition that separates our species from every other species. And so getting to learn language in a way that's not only sort of elementary school level, but at the professional level, that can get into, understanding tax regulation, as I was saying before, or getting to understand, oncology or any one of your cardiovascular diseases, right? That level of understanding requires you to understand, let's say, publications, but also patient records, your financial events in your life, et cetera, et cetera. So I think there's a combination of multiple sets of algorithms and tools that are coming together in almost a platform. So Watson is now a platform that allows you to build applications in your industry And that's happening now with tens of thousands of developers building many applications. I think that's why the whole set of industries are transforming, like I was saying earlier.
And since the focus here is on your industry, right, let's maybe take the temperature of the audience quickly. When you read about AI and the transformative potential it may or may not have, how many of you think opportunity? How many of you think danger? Okay, so maybe a few less, but in light of that, yeah, David.
Can I just mention, apropos of what we just heard, I'm a tremendous admirer of Watson. It's a hell of a piece of technology. But when you say it's doing a bunch of things, it's doing a very incomplete bunch of things. When you talk about the ability to understand language, I need a machine that can understand language, and not only the way I understand it now when I'm reasonably awake and alert, but the way I understand it later in the afternoon when I'm tired, when my memory is operating in a much freer, much more vivid way, when I'm much closer to free association than I am to any kind of rational, logical thought. As I approach the boundary of sleep, the character of my thought changes radically. At some point, I'm beyond the point at which I'm going to get anything valuable in an applied sense. It's interesting to wonder how we dream, but I don't need a computer to dream. I can do that myself. But the normal range of human daytime life between highly alert and tending much more towards intensive use of memory, towards vivid memory, towards freer use of memory, towards freer use of emotions, and less reliance on logic and analysis. The fact that every child knows that the human mind is dynamic and not static, that it changes constantly throughout the day, through the course of a day, through the course of a lifetime. Every child knows that, but very few people in AI do. And until I have AI software that can replicate not just the very top edge of the spectrum, but the entire useful part of the spectrum, the first AI has to know the spectrum exists. It has to know some basic philosophy of mind, some basic mind science, and that has nothing to do with replicating the brain. It has to do with understanding the mind, and that's where we're not progressing as we should be.
So I think what you're pointing to, David, is a distinction between the kinds of tasks that we're seeing now that might be subject to the kind of automation with available tech, and then there are tasks that seem to be out past that, and there's different classes and kinds. And so maybe for the benefit of the people here who are running businesses that could either be affected by these things or not, what if we talked a little bit about, the tasks, the kinds of tasks we've seen AI and automation take over, and the kinds of tasks that present, in the estimation of the panelists, the low-hanging fruit, like the next stuff that's going to go, given the technology package that's available now. So maybe, Stan, would you start? How are you guys seeing this play out at Zillow?
Yeah, so from the early days at Zillow, a lot of the initial stuff that we worked on around trying to value homes at scale, involved a lot of machine learning approaches, and we continue to invest heavily in that now, not only in valuation technology, but in technology around personalization and a lot of things around text recognition, text mining, computer vision, and deep learning, where you are, I think to David's point, you're right that there was a grand vision in the 1950s and 60s for artificial intelligence that it would try to understand and ultimately replicate what the human brain is doing, which is a synthesis of a whole bunch of discrete tasks and putting that together into an autonomous way that can reason independently. And that ended up being a vision which was ultimately too grandiose at that time. Instead, the task devolved into one, or at least the vision devolved into one of a myriad smaller tasks, which were much more applied, and lost that sense of the vision of having a autonomous, independently reasoning system. Instead, it was a system that tried to tackle discretize that problem and tackle the individual applied parts, like, can I train a computer to look at an image and figure out whether that's a nicer house than the one on the left versus the right? Or does this image have a Viking refrigerator in it or granite countertops? And you're right, relative to the vision of the 1950s and 60s, David, that's a much more pedestrian, less grandiose vision. But I would say that we've made a lot of traction about solving those problems that actually do create real business value. And your discussion about can we make text reading and voice recognition, there are problems where it is still far from its full potential. That's true, but I would say that that's true for, that would have been a critique for cars relative to horses when they first came out as well. And eventually cars were able to close that gap, and I think that for voice recognition and computer vision, there are enormous gaps in those technologies between what a human can actually do. Those gaps will be closed. What will remain for the moment very challenging is the synthesis across those applied domains into the original vision. That's going to be hard.
And Ralph, at Amazon, could you answer a similar question? What kinds of tasks are you seeing susceptible to, disruption by AI? What kinds of tasks, and what are the next ones that are the low-hanging fruit?
So actually, I would like to take your metaphor a little further about the rail. So if you didn't have the combustion engine and you didn't have a way to burn coal in a way that you transform the energy, you couldn't have a train. And AI, one of the things that is central, that's often not spelled out, is data, is labeled data. So when in '97, when I wrote my diploma thesis, I had 10 images to train on. But the algorithms I used, this was labeling an X-ray image for the spine. The algorithms I used were very similar, if not identical, to the ones we use today. And I think when we answer the question, where can AI today make a disruption, is the first central question is, do we have sufficient amount of data? A good example is when we started the X-ray project. So this is for books, for indexing books. We first needed to collect data, meaning people needed to read them and annotate them. Where is a person of the story mentioned? Where is a place mentioned? Similar for the speech recognition. So I think the central question that we always ask is, do we have a mechanism, either do we have sufficient data, or do we have a mechanism to collect sufficient data ongoing? Because if that's not the case, then it's the same as trying to run a train without burning any coal or any form of energy, and that's not going to work. So,
and what kinds of tasks then are still proving uncrackable for AI? And if this can be either within your own businesses or how you've observed, in domains outside of your own. Guru, do you want to take that first?
Yeah, let me start with a very practical example, and I'm sure others can add to this as well. Think about the doctor that you go to for any of ailments that you may experience. Probably that doctor is 5 to 10 years behind the curve on the latest developments in their field, just because they don't have the time to read all the scientific articles, and they pretty much go from their experience. So imagine now, in a new world, if there was an assistant, a doctor's assistant, a cognitive assistant, who was able to help them do certain tasks in their normal process. So let me go through a scenario, right? The doctor first has to interview you as a patient and get through, empathically, a lot of information that will make a difference in the final analysis. But then they have to go look at the options, differential diagnosis type of options that they have to then evaluate. I think a machine can help bring in the, several options that may be based on the observations, but also based on literature, maybe the experience of other doctors and so forth. So bring the different options is a task that a machine can do really well. Beyond that, maybe there's a lab test, and the lab test is a very routine, sometimes it's a very boring task for somebody in a back dark room to do, and probably they're going to experience a lot of errors. So get a machine to do that and get higher degree of effectiveness, accuracy to get that task done. But then finally, at the end, the doctor has to make a judgment call about what to do and then fit the treatment plan to your lifestyle. And also, legally speaking, the doctor is responsible for the ultimate decision. So the person is more responsible for doing at that stage of the process. So as you go through one of these kinds of processes, I believe machines will augment many of the tasks, but that has to be designed very carefully and appropriately for the business process. And we've done this now in many industries. Even in the financial service industry, I can go through a similar process and say which tasks are good for machines and which tasks are good for people. Typically, the people-oriented tasks are much more about human relationships, about judgments and values, about what we call common sense, which is still a difficult research topic, and it's been going on for a long time. Those are the kinds of things that, from a practical perspective, I would still leave in the hands of people.
Regarding common sense, why is that concept so difficult for machines? David, do you want to take a swing?
Well, if I could just comment on what we just heard, I think the entire field has agreed that developing AI consultants for use as second-in-command, for use as tools in the hands of expert human beings in the medical system is the right way to go. Everybody believes in it, but in the long run, it's impossible. I don't think very many people believe that will be achieved. Once you have the assistant in hand, once the software is there, it's so much cheaper to consult the assistant, to consult the software, than it is to consult the MD. There's no way that you're, or any kind of trained expert, there's no way you're going to be able to prevent the construction of direct interfaces, I think. It's just a guess, but I think between the AI consultant and the public. And so it's ultimately our aim, whether we choose it or not, it's our goal, it has to be our goal, to develop assistants that can truly be as intelligent as possible with common sense, with the attributes of a general human intelligence. It's not merely a philosophical or scientific grandiosity, and I would be wary of dismissing it as merely grandiose. I find it hard to trust somebody who has no sense of humor, for example. I find it impossible to talk to somebody with no imagination, with absolutely none, with no ability to make a creative observation. It's fairly clear that imagination and creativity are associated in many contexts with the invention of new algorithms, new analogies, more than new algorithms. The invention of new analogies and of new comparisons. That is when something reminds me of something else, when I use my memory in a particularly broad-ranging and flexible way. Now, the field loves to pick these things up as separate, discrete tasks. So we've solved the applied consultancy and medicine problem, not really, and now we need to solve creativity, and then we need to solve common sense, and then we'll take a look at sense of humor. That is also a non-starter because the human mind is a continuum. Different minds work in different ways, and for that matter, at different levels of effectiveness. But we know that the mind is a continuum, and unless we make some effort to capture the continuum in reality now, we're not going to have an assistant that is going to be trustworthy. A lot of people will trust it, but it's not really going to have earned their trust. They're going to trust it automatically without, and they're going to be misled.
Even if we take a step down the ladder from things like a sense of humor or general common sense, just to certain kinds of physical tasks that require a pretty good grasp of contact mechanics, for example. I've read stories about the Amazon warehouse robots, for example, and there's stuff that they do really well, but there's stuff, just physical, boneheaded, physical stuff they can't do yet. Ralph, I know you don't handle the warehouse robots, but
yeah,
you probably know more about it than me, so can you talk a little bit about the distinction between those two tasks and why some of them are hard?
Absolutely. So we have so one of the things that it can do really well is, we have them for navigating, basically driving, picking shelves, pots of goods up, and bringing them from the position or from the place in the warehouse to the person that's picking from them when you order, or it's going into them. And that has huge advantages because the associates no longer have to walk that way. It also has advantages because you can pack the fulfillment center a lot more densely. Now, you would think with that kind of technology, you could learn you can learn something as grasping. But grasping is highly complex because it's a closed feedback loop where, even the task of grasping, picking this pen up involves, when you study it in a slow motion camera, it involves the sense where my thumb is sensing constantly, constantly whether or not there is enough force to lift it, not to break it. And grasping something with a grabber, with a mechanical hand or other devices, is so hard that we actually started a research, we had a research challenge that we started 3 years ago, the picking challenge, simply to see. So we had a small number of products, tens of products, and had teams, we sponsored a prize for picking the most items out of a shelf. And it was surprising to us. I think the positive news is it is possible to do it to some degree, but the speed by which machines do that, and the amount of processing required, because the other interesting effect is that if I grasp a pen, if I grasp this bottle, I use completely different forces, but the signal processing is happening in my hand. It's not constantly going to my brain back and forth. That's not the processing pattern we currently employ on a computer. We think the CPU, like a central processing unit, computes everything. So there's a lot of research actually needed to grasp well, and that's something that currently associates do in our fulfillment centers.
So I was recently interviewing an AI researcher who told me that it's easier to calculate the precise trajectory of a comet than it is the trajectory of a coffee cup sliding across a table. And he said it has something to do with Moravec's paradox. Could one of you explain what that paradox is?
I don't know that paradox, but I had an interesting quote by a colleague from Cambridge. It's called Carl Rasmussen. He said, computers can compute the best move against a human in chess, but they cannot move the chess piece. And I think that's a good characterization where the technical challenge lies. So machines can beat us in Go and in chess and others, but just touching a chess piece and moving it to the next position without ruining the board is such a complex task. Like, it goes way beyond. Because I think that one of the challenges is when you learn to play these games in a digitized universe, you match patterns. I mean, that's effectively, your answer. Where is it going to replace? Is pattern matching is what these ML or AI algorithms do really well. But there's tasks where either patterns are very complex, like the pattern of grasping this pen, or pattern of grasping is a whole program of steps that I need to execute. That's a huge space of patterns to search. And right now, algorithms are very data wasteful, much more data wasteful than we humans are. And so the amount of data, even by self-play, that you would need to do to learn that is so enormous that it presents a challenging task, and it probably requires an algorithmic innovation more than just thinking you can run millions of years to eventually have enough of this data.
And this term machine learning is thrown around a lot. Every third story that I read about AI seems to involve machine learning. And so I'm wondering, for those of us who may not have a good working definition of what the hell that actually means, could one of you explain it? Maybe I'll have Stan, you've worked for NASA and you've taught high school physics to kids in West Africa, so take a swing at like a simple definition of machine learning.
Sure, yeah. I mean, I guess it's the most basic form. The field of machine learning is about using generally a computer algorithm to mimic a process of decision making itself. So, a classical approach to a classical algorithm you might find in machine learning literature would be a decision tree, where you're trying to predict an outcome and you're building a decision tree based on your inputs that gets you to a prediction for that outcome that's designed to mimic, in a crude form, what people thought the human brain is actually doing. The reality is that the human brain is doing nothing like that, but it is useful, and it turns out it is useful for predicting things, even if it has no analog to the human brain. I don't know if that was simple enough or not.
Pedro Domingos at University of Washington has a nice definition. Like, a typical computer takes inputs and then runs a program that interprets the inputs to compute an output that comes on the screen or on the printer or actuated. I think one of the things that machine learning does, it takes outputs that often people do, like actions they take, clicks they do, and inputs, and it computes a program. I think that's why it's so exciting. Rather than typing these rules down, rules are programs. It learns these rules, so it turns an observed output from an intelligent process into a program. Now, machine learning is agnostic where that output comes from. So if this output comes from someone with intelligence, you might argue that it learns to mimic an intelligent task. If that output comes from another machine, it would just learn to mimic that task.
Yeah, I think it's that iterative data-driven approach that has led to the synthesis that we see so oftentimes today of the synthesis between computers and data, because for a lot of these machine learning algorithms, they are so data intensive in order for that algorithm to be able to infer the pattern that then leads to its ability to generalize on data it hasn't yet seen and be able to predict what future behavior is going to be. So, in our space, trying to estimate values of homes, trying to understand future trajectories of home prices for neighborhoods, trying to understand features that homes may have that users may want, trying to understand, based on what people have looked at, what they want to see next. Those are things that are very data intensive, and machine learning algorithms paired with that data are providing the solutions.
And in terms of the results you get out of those kinds of systems, my limited understanding of how this works is you have a big data set, you have a powerful, let's say, neural network computer, you turn it loose on the data set, you reward it when it gets right answers, you correct it when it gets wrong answers, you go through several 100 million cycles of this, and at the end you start getting behavior that's useful to your business, or behavior that beats the champion at the board game, or whatever. But it seems that a lot of the researchers who work with these systems can't explain how the system arrived at the decision rules that it arrived at. That neural network's a black box, and I'm wondering, for business processes, if I'm getting this right, can that lack of transparency in the system's decision rules cause problems if you care about how you get an answer as much as the answer itself? What do you think, Guru?
So
And then David.
let me start. One of the implications of this process of machine learning that you just heard about is that people have to learn how to best use the system. So, what you don't necessarily realize is that if you ask a learning machine a question today, and you ask the same learning machine the same question tomorrow, it may give you a different answer because it learned something overnight that maybe made its answer better than before. So this point about trust between a person and a machine that they interact with is absolutely crucial. And the way you establish trust is, in fact, if the machine behaves pretty much as you would expect a machine to behave, or maybe expect an intelligent agent to behave, where I would expect anyone that gives me different answers on different days to be able to tell me why their answer was different. So I would say, how did you come up with this answer? And if the machine is not able to give me the reason why, then I would not trust it. So in some fields, like in medicine or law, this is absolutely essential. Otherwise, you would probably not pass the basic certification exams that are required for a person or a machine assistant to even practice. However, pieces of the machine learning can be transparent through evidence-based explanations, through conversational explanations, and we've demonstrated that in many fields. But there are pieces like some algorithms, for example, neural network-based, deep learning, very complex algorithms that today behave like black boxes. And we need to invent new technologies to be able to combine those along with the more transparent pieces of the system so that people can understand why they behave the way they do and trust them.
Is this black box issue one of the reasons why you think AI is stuck, as you said, David?
Not really, although it's certainly an important issue. I think it's important to keep in mind that machine learning is by no means the same as neural networks. A neural network is one algorithm, is one way to build an AI program, and it works well in some context. It has real problems, namely its opacity. There are some fields in which opacity renders a system a non-starter, as we've heard. When I was a graduate student, thousands of years ago, working in medical AI, and if you asked diagnosticians how they went about their work, it was clear, back in the 1980s, there was enough data and enough statistics such that simple Bayesian analysis of a patient presentation would give you a far more accurate diagnosis than the average physician could. So the question was, why not throw out this diagnostic process of interviewing the patient, doing these tests and all this stuff, or after you've interviewed them, you feed the data into a simple Bayesian analysis. The answer is no patient is going to believe you. A patient doesn't simply want an answer. You've got tuberculosis X. It wants an explanation. Because of this symptom and that symptom, I'm led to think that you may have this, but this makes me know that you don't, that it's tuberculosis, but it's benign tuberculosis X because I can see from the color of your hair, blah, blah, blah. People need to hear that. The more serious the area, the more important the explanation is. So the black box is just not going to cut it. And as Guru says, the fact that we have an opaque neural network doesn't mean we can't install a parallel system that explains what's going on, that interprets, that takes a guess as to why the system converged the way it did. But the explanatory aspect has got to be there, and it's got to be convincing. It can't just be an add-on or a footnote.
Yeah, I would say it's an interesting question because, first of all, it's driven by a desire to be more accurate. So there is machine learning methods that produce classifications, predictions that are human understandable, but they're not as accurate as the ones that are we call nonlinear or neural network, like more complex in the way they derive the decisions. And it's our drive to more accuracy that actually makes the systems more black box. I think there's another aspect. I think it'll take time for society also to build mental models of these autonomous systems, because I think the black boxness doesn't come from AI. It comes from complex systems. Like when you think about your car, like how many people here drive a car? How many people know exactly how the combustion engine and the differential in the tires work? Very few. But you trust your life on that steering wheel and that gas pedal. So because you have a good mental model, what happens if you press the gas pedal and if you press the brakes? You could study every single step of how the combustion actually works and how the brakes works and how the differential works when you corner, but you still would be hard pressed to explain every single move that a car does. So I think some parts of this complexity is what drives the black boxness, and it's not particular. It's not just particular to an AI system. I would also say the first aspect, that the accuracy is higher, as David was saying, is pointing to an interesting bias that people have. Like, we'd like simple explanation, and we'd like a doctor to tell us, because you had a black spot there, you need to get treated. But the reality is probably more complex. So there's a certain comfort we take in a human explanation, even if it isn't the full story. So if you take an example from Amazon, there are systems where it's really critical to explain what's going on, even though there's some nonlinearity. So people that bought this pen also bought another black pen. Now that's a simple explanation. Now there is still some complexity because people who bought this pen, there's about 20,000 other items that they also bought. So now sorting the black pen first and the cover for this pen second is a nonlinearity that doesn't need explaining, because the simple explanation of co-buy is a good mental model that allows us to understand why that recommendation arrives at us. And last thing I would say is there's some tasks where the explanation, a bit like the car, isn't as necessary. So if you think, like one of the things we do is we translate all our products and product descriptions in Europe. For a seller, it's not that critical to know how exactly we arrive at a translation of blue ball pen into Italian or into French, as long as the sales of that product in the Italian and French market is reflecting what it sells in the German market. So if some of those decisions are not necessarily needing explainability. I think when it affects an individual and has profound consequences, like my wallet or my life or my safety, then an explanation is important.
So
It's not a black box, even if I don't understand the engine differential, so far as I interact with it.
Yes.
If I can predict the interaction and predict it correctly, then I know what I need to know.
That's right, because you interact with it, and that's, I think, what's going to need
Right.
necessary is that people interact with these systems. People interact with search engines. They build a good, easy mental model. What results they're going to get? If people interact with the search in products, if people interact with Alexa, they get a reasonable mental model how that speech recognition works, and that's. I think that's what's needed. This mental model of how the black.
Making predictions, and their predictions come true.
Yeah.
They're satisfied that they
Exactly.
understand what they need to.
And they don't need the details of exactly how does the training update correlate to a change of the parameters, which then results in.
Well, except when you're audited, if you make a very complicated financial decision or a health decision,
Yes.
and there is a legal reason why somebody needs to understand exactly what happened, then you need to get all the way in. And so, I would argue that there is a sort of a conversational or maybe a progressive disclosure type of an explanation that's required for somebody who has a high-level mental model and it works fine. That's where they need to stop. But if somebody needs a deeper explanation, systems, especially that are in the critical domain, have to be able to provide that. And if you say that the machine can never give you an explanation, that is a non-starter.
I think the idea, what you just said, Guru, about kind of progressive discovery around the why behind the prediction is important, and we've seen that in our space where we've tried, when we think about predictions on things like a home price, there's a way we have tried approaches that try to be intelligible to a user, where we might say, well, your location is worth this much and the structure is worth this much, which we think is a more intuitive way, or a intuitive way to people to think about value. The reality is that those approaches are far less accurate than a pure opaque black box model. So those are, while you have some interpretability, you don't have the accuracy that the user would like. So we use more black box methods, but then we experiment with ways to progressively show the user more information. I think to David, your point about kind of providing the user would have some expectation, as long as they can expect, their expectations are confirmed in the process. So if we can provide a much more accurate valuation of a home, but then, which is very accurate until it's not accurate. So we can have a very low error rate on valuations, but there'll be some home that for some reason has instead of a 4% error rate, has a 20% error rate. Yeah. If you can, though, then provide some additional details into the black box that helps you understand, other ways that it got there, so that you can see that it allows the user to say, well, I'm not sure that's right.
Exactly.
And then progressively go in and see, oh, I see if I think about it, it's this prior sale of what I bought 3 years ago that's actually making this thing, and that prior sale I happen to know isn't right, it was a foreclosure, and therefore they're allowed to discount and know when you're looking at a 4% error rate versus a 20% error rate.
You have to remember, of course, the kicker case of all these explanations is that in the limit, if you are faced with substantial enough expertise, you're willing to forego the explanation. Most chess masters and grandmasters have no concept of why it is some do, but they don't necessarily know why they moved where they moved. By the same token, if you were dealing with a financial advisor who had made $100 billion for his average client and his average success rate was 99, some fantastic success rate, and he gave you advice by going into a trance and buy this, sell that, and he had no idea what he was telling you. He couldn't provide an explanation. Nonetheless, if he were good enough, if his record were good enough, you'd probably listen to him. I would.
It sounds like in a lot of ways you guys are saying the nature of the task itself determines how susceptible it is to current AI technology, but also the cultural expectations surrounding the task. Is it subject to audit or not? Is it the kind of thing we need explanations for or not? That also would help determine the extent to which it could be disrupted by AI. And so when you look out at industries outside your own, where do you see the other places where you think this technology is going to come rushing in the next 5 or 10 years? What are the
Industries such as what again?
Industries outside of the ones you've currently discussed? I speculate beyond, for the benefit of people here who don't work in the specific domain you work in. But when you look out and you see the kinds of tasks that are automatable, given what you know, like what are the next places where we're going to see a lot of action?
It's ubiquitous. Any place where there is a task that involves some notion of prediction, which typically a lot of advice-type tasks are predictive tasks, and there are labeled data sets, meaning that you have a body of corpus where you have good decisions and bad decisions, then those are ones that will certainly be the subject of this.
Yeah, I
and,
strongly-
you know, we were talking last night about like legal tasks and like, you know, what if legal tasks would get will get worked away, and you know, we've already seen it in document discovery and now in maybe more due diligence type stuff, but you know, the stuff that anything that involves some predictive thing of are people talking about this in this corpus, then of course that's going to be machine learned away. What will be left is stuff that is on the edge where machine learning can't quite figure out how to get there, and certainly things that involve more concierge functions of piecing different disparate areas together, because that requires a real ability to independently reason, and that's extraordinarily hard. Back to David's original point, that gets more to the original vision of AI, which is it remains frustratingly far away.
Guru, you wanted to?
Yeah, I think that it's going to impact pretty much every industry, because every industry is now based on advanced, data processing and knowledge, let's say insight generation and decision making based on all of that information. I think from my own experience, I deal with clients in pretty much 20 industries maybe, which is all of the industries that IBM does business in. And we have started to now engage certain task level AI engines in all of these industries, including education, where I think it's pretty fundamental, because I think the next generation has to kind of grow up learning how to work with these learning reasoning machines. And professionals who are going to be trained in college have to learn how these machines work. I mean, my favorite example, if I can just end with that, is doctors may have to be taught not with stethoscopes, but with datascopes from the beginning, from day one in college, medical school, and so they can really understand how to work with all of these technologies that are going to be available in the future. So it's every industry.
I think there are two areas in particular I would buy if I were investing in AI futures. One is skills education, the level of reading and writing. We get at Yale the best students in the world, certainly in the country by far, but most of them don't know how to read and write. Well, by far. Yeah. But the basic skills they arrive with, although they're brilliant in many cases, they've worked impossibly hard to get into Yale. They're much more polite and better mannered than my generation was, but they don't know anything. And in particular, and it's easy to tell them the facts they don't know, but they don't know how to write. They don't know how to read. In order to learn how to write, they have to write 300 words, 200 words, small pieces, a paragraph. They can't write a single sentence passably, and their tiny essays have to be graded in enormous detail, in enormous tactical detail, and that process is to be repeated again and again and again. And then they can improve. Anybody can learn how to write, but it's an incredibly time-consuming process. Now, after I have graded 100 million words, the algorithms are fairly clear, and there are always unexpected things, and obviously a person's personality is expected in his writing. Nonetheless, 95% of this editing, of this copy editing, could be done by a sophisticated AI program. Desperately has got to be done, because the students we're graduating their ability to use the language is gradually coming apart. We've got to do something about it. And we have another pressing problem right here. Getting into the city and moving around is impossible. I don't know if you've noticed. There is no solution to the problem of how to get from New Haven into Manhattan. I mean, you bounce from one alternative to the other, and they're all impossible. I mean, clearly we need computer-controlled transportation networks, and we need alternatives like getting your car, driving to a certain point, and then being picked up by somebody set out to meet you, saying, park here. If the traffic is heavy, you're going to leave your car further towards New Haven. If it's light, you're going to come almost all the way into the city. But we need coordination. Not right now. I mean, we need it this afternoon. Just as the writing problem, the reading problem, and there are similar problems in mathematics, it's just that writing is more important. these have to be attacked.
Well, the stuff about the student writing I take kind of personally because David was my professor at Yale. He graded some of my writing. So the suffering, I think, is caused partly by me. So you cut me deep, man. Ralph, when you look outside, you've worked for Facebook, I believe, for Amazon and for Microsoft. Is that right? And
Yeah, not in that order, but yeah.
But when you look outside of those industries to others, where AI might touch or change, what are you seeing? What's your prediction?
I mean, as I said, the oil of the coal of the steam engine is the data, and before it comes forward. What comes before data is sensors. So, the problem in 1997 was not that we didn't know in the digital world what to do with a bit of pixel intensity to classify. The problem was that capturing this was a very costly and time-consuming process. You had to go to the university hospital to even get one digitized image. And if I had to make a prediction, by the way, I'm not very good at that. I think most of us scientists are not very good at that. If I had to make a prediction, I would kind of look, where is more and more sensors, stuff that turns atoms into bits, become prevalent. And so one area that I personally see, I'm quite into sports, and I see that the equipment that top athletes had 20 years ago is now available for 20, 40, 50, $100 to the average person. And I feel there is a lot of interesting data that helps for personal health, helps for, in the space of eating a bit of eating healthily, of exercising healthily, becomes available. So I think health in the sector for because we can augment, we can see what you eat, we can see which exercise you do, we can measure people. A watch that basically measures every 2 minutes what my heart rate is. There's interesting data here that could sort of probably predict the onset of some conditions I have way earlier than I used to. So I think the health industry is definitely a big one. But generally, like, my calculus for this is there a sensor that turns a physical, is there an emergence of a sensing or an actuation in the real world that turns something that happens in the real world into data? And then that will bring with it the data, and then often the patterns that need to be detected in order to make predictions about help for convenience is sort of the last step in that chain. So
we've got a few minutes left, and I wanted to start bringing in some of the audience questions because many of them are smarter than mine. The reason I personally got interested in all of this stuff is embarrassingly simple. I liked robot science fiction, and I thought coming to a room full of lawyers and business people, none of you would be interested in the sort of sci-fi side of these questions, but several of you asked about the singularity. And so since it's not my fault, it's yours, I wanted to at least put this idea out there. The sort of, and a way to kind of frame this idea is there's a very anxious narrative out there in the popular culture about what AI is, where it's going, and how we could be faced with something unprecedented and alien that's going to sort of be upon us overnight that would change everything and maybe change our status on the planet. And so, since again, it's not me asking this, would one of you care to take on the more apocalyptic side of the popular culture AI anxiety here?
Well, I'll just say if there's an upside to David's less than sanguine disposition towards the overall AI, it's that we shouldn't be too concerned about the singularity anytime immediately soon, because that grand vision, I think we're pretty far away from that. I don't know if you'd agree with that.
I have to agree. I do think that we are a rule-following species if we come to clear conclusions. We're capable of safeguarding ourselves, and it seems to me that no one has a right to build a machine he can't control. And if we were, and I think that's as true of chainsaws and washing machines and robots as it is of software in itself. I think if we came to agreement on that and 10 other, I don't know how many, it's a small collection of simple guidelines. The human race is, if one had been told in 1945, after the end of the Second World War, that the Nagasaki bomb would be the last deployment, the last use of nuclear weapons through 2017, and forever, maybe, God willing. But certainly, if somebody had been told we won't see them again as of 2017, nobody would have believed that. The world was on edge. The world was desperately afraid that these weapons, and very soon they were in Soviet hands also, would of course be used as soon as the United States or the Soviet Union got embroiled in a war that it couldn't win. And they both did during the Cold War. But we managed to restrain ourselves. So do all the other holders of nuclear weapons. We are capable of restraining ourselves on the whole. We know what the rules are. We need to agree on some guidelines, and if we can, and if they do represent a kind of consensus and not an imposition by the intelligentsia, I think we'll be okay.
Guru?
Well, my view is that many of these AI systems are already superhuman along certain dimensions. And we actually want them to be superhuman on those dimensions, such as, reading a zillion papers and bringing them to me when I need to make a decision. That's a superhuman ability. And I think we want them to do those kinds of tasks. Now, will a machine get to superhuman along every single possible dimension? I think that's what people kind of associate with this idea of singularity. I think that's a very far-fetched idea, in my opinion. And I definitely not, my usual answer is it's not going to happen in my lifetime, okay? But it's so far off that as a practitioner and as a technology developer, that I couldn't even put a timeline on it.
Yeah, so my view is, I think it is super exciting right now to work on AI because it becomes, we are in a digital world, but I've been in the research field for nearly 20 years, and what I find interesting is that right now a lot of people see the benefits or the effect that AI systems have in their lives and in society, but a lot of that research still dates back 10, 15, sometimes 20 years. So, we're getting excited about self-driving cars, but that work was demonstrated in one car in 2006. That's 11 years ago. We get excited about deep learning, but the math of deep learning was developed, most of it, in the early 90s. So that idea of, I think if I had to predict what's going to be used and in everyday use in 2025, I would look at the current scientific conferences. What is the research prototypes we're seeing? And nothing I see so far on the research horizons has kept algorithms that are able to write, invent, learn new algorithms. So this sort of premise of acceleration because you kind of learn to learn. So that's why I think, I take this a big grain of salt. I do think the fact that most of the technical advances happen in research labs and in research groups and in small-scale conferences make the emergence all of a sudden appear very sudden, but a lot of the mathematics behind it is not so sudden at all. It's a continuous stream of scientific progress.
So I'm going to just read this question verbatim because I like it so much. AI systems have been known to reproduce their builders' biases. How do you ensure that they're ethical, especially given the opacity of the systems themselves and business pressures for efficacy rather than ethics? Stan.
Yeah, I think that's a great question, and because there are a lot of ethical issues around. So certainly the training, which I think the question invokes, the training of the machine learning algorithms pose. I think generally the community is increasingly aware of ethical and moral issues around the training of that. There's also some larger set of ethical and moral issues around job displacement and things like that, which I don't think the question exactly wasn't. So I'll just touch on the first one. In terms of training, yeah, you're absolutely right that there are, to the extent, in my prior answer, I discussed the integration between computers and data, and specifically I mentioned labeled data sets. So labeled data sets suggest that people have made this decision before, and it assumes that that decision was right and was ethically and morally, there was no normative, wasn't a normative decision. And of course, a lot of those decisions that we actually do train on, for example, your probability of getting a mortgage or living in a certain neighborhood, which may be using data that is from historical redlining cases, and therefore has a ethical bias built into that data. And if you're training on that, then that can create problems, even though you did not intend for. You don't have an ethical bias in your work. So, that's something that I think you need to, as practitioners in the field, we need to think about what is the problem you're trying to solve, and what is the data that you had to collect that problem, and what might be this potential, whether that data may have come from an environment that was constrained in some way that has ethical or moral implications.
Guru, are there ways you see this coming up in the medical field,
Yeah.
for example?
This is such an important question, and I think it cuts across all of the professional domains that we are all engaged in. That Ralph and I actually are part of an organization that is cross-industry that we've just launched called the Partnership on AI, and we've come together even though there's a lot of us are competitors. Google DeepMind, Microsoft, Amazon, Apple, Facebook, and IBM. We've come together along with 6 other non-corporate organizations to understand all of these ethical issues across the board and to create a forum in which everybody can engage from their respective industries, professions, and practices and bring up the issues that matter and how they could be addressed, right? So I think this is a much broader conversation than technologies alone. This is not going to be solved just by those who create the technologies. And therefore, this becomes a forum in which we can engage the broader community, starting with lawyers and financiers and so forth.
David, you've been a bit skeptical about the need for the discussion at this stage, or how would you put it?
Well, I'm pleased, impressed that the AI community thinks about ethics, talks about ethics, wants to spend some of its time and energy figuring this out. This multi-company consortium to address ethical questions is a fascinating development. I don't know what they'll wind up doing. I wish we in AI made more use of the ethical resources at our disposal, which is not lawyers and financial consultants. Those are not the people who come to mind, nor academic philosophers, academic ethicists. Those are not the people in whom I put my trust. I wish that priests or ministers or rabbis, religion doesn't consist entirely of adjudicating ethical questions. I mean, ethical questions are maybe a third of the Judeo-Christian tradition, but nonetheless, we have, it's not productive for us to treat ethical questions as common sense matters that anybody's snap opinion is of equal value about. There are many people who've given their lives to study and thought on these issues. They're not of equal depth and authority, but there are many impressive authorities, and I wish they were closer to the AI community, and I wish the AI community didn't have the reflexes of the academic world to reach for another academic rather than someone outside who deals with reality and not just.
For me, the ethical side of this, if the railroad is the right analogy or is closer to the right analogy, that suggests that this is a form of technology that's going to find its way into many businesses, many lives, many cities, many homes. And when the railroad did that, there was a new form of disaster that was present. And, I'm a newsman, and it got covered in a big way. Train wreck is a dead metaphor now, but when they first started happening, they were catastrophes of beyond imagining. And they really freaked people out. The idea that you could die in this grisly new way at the hand of this new technology. And I'm not saying that perhaps the stakes are quite this high in this case, but technology goes wrong. That's one of the things that happens in the story of tech. And so I'm wondering, when you look at your own operations or you look at the work that you've done, are there ways that you think we should prepare for this technology not doing quite what we'd like it to do, or this technology going in directions that we didn't fully anticipate? And is there anything that people can do to, sort of guard for that? Ralph?
Okay.
You looked like you had an answer, so.
I see. No, I think there is definitely needs to be taken care of, and I think I would say there's two aspects that we're at Amazon already taking care of. So one of them is when you deploy a system. It's like, to take a railroad analogy, when you sort of roll the trains out in a completely new country, I think there's two aspects you need to consider. First of all, you need to test is the supply in coal, is the supply in energy sufficient? So what we do is whenever we roll a system out, we're not going to switch it fully over, but we slowly deploy this. I think another one is these technologies are helping humans in decision making. So there is an interface that you need to think about, like what's the benefit, what's the pain point you're solving for a person, and what's the benefit they're having. And so one of the ways that we do this at Amazon is that there's a technologist, and you can start, you can say, well, we have this data from purchases, or we have this data with annotated speech, and let's train a neural network on this and see how well we can predict the purchase pattern, or how well we can predict the speech signal, the translation into actual phonemes and then words. But then there's a process, how is that going to affect the customer's life? And so the way we do that is that we don't start with a technical challenge. We actually start with what is the pain point we're solving with this technology? And we sometimes spend 1-2 months on this. We call it a press release FAQ process, where we first try to describe how that technology is going to interplay and how is a person affected by it interacting with it, what's the interplay like. And I think that's a healthy way to start the sort of product development, because you're thinking about how it affects a person.
So we've got about 1 minute left, so David, I'll give you the last word on this question and then say thanks.
It's a hard thing to say. When will AI be beyond our control? Is that something that will really happen? Will we build a program, will we build a robot that threatens us, that threatens to break away from us? It shouldn't happen. We have to remember that AI has been surprising AI researchers from the very beginning. My father was one of the originators of the field in the 1950s and the originator of AI at IBM. He wrote a program called the Geometry Theorem Proving Machine, which was one of the first, it was number 3 in the world of the third AI program, the first that actually did anything. And it drew a tremendous amount of attention and coverage when it was proving theorems in high school geometry. It discovered a proof for the equality of the angles in an equilateral triangle that was, that people said, wow, that's the cutest proof I've ever seen. It was a proof in which that centered on the triangle being compared to the mirror image of itself. And people thought that the machine had actually invented the proof. It turned out an ancient Greek mathematician had come up with the same thing. But it was an exciting thing. People said, wow, this is good. So AI has been surprising from the very beginning. But does that mean that AI necessarily has to be beyond our control? And the answer is no. We should take the responsibility for saying it's our responsibility, our meaning the AI guys in the labs or in our offices, wherever the hell we are. It's our responsibility for making sure that that doesn't happen. We have a moral duty in playing around with this kind of technology, and it's up to us to take measures to make sure that while we're constantly surprised by what we do, we're never out of range of the off switch or the plug. And we can do that if we make it our business to do it.
I wanted to thank all of you guys for your time today. Thank you for your time, and have some lunch.